Hello and welcome to my Algebra 1 review series. This video covers Chapter 9, Section 5, titled Factoring Trinomials of Type x squared plus bx plus c. By the end of this video, you will have reviewed past lessons describing the methods of factoring trinomials of type x squared plus bx plus c. In the process, you will review factoring types x squared plus bx plus c and x squared minus bx plus c trinomials and trinomials with negative c terms, and finally factoring trinomials with two variables. If you'd like me to cover any of these topics in greater detail, please leave your request in the comment section below. Please subscribe to this channel if you find this video to be helpful. Thank you. Okay, Objective 1, Factoring Trinomials. In earlier sections, you learned how to find the factors of whole numbers, like 15. Since 3 times 5 is equal to 15, 3 and 5 are factors of 15. You can also find factors of some trinomials. Consider the product below. The quantity x plus 3 times the quantity x plus 5, right here. This term right here. If we multiply that out using FOIL, we're going to get x squared from the x's here, the x's, the firsts. We're going to get 5x and 3x by doing the outer, which is x times 5, and 3 times x right here. Okay, 5x and 3x, that's these two, 5x and 3x. And then finally, we're going to get the 3 and the 5 multiplied together to get the 15. 3 times 5 is 15. And you see how we used the distributive property right here. To pull the x out of these two terms, we added the constants or the coefficients of 5 and 3 to get an 8. And when we're finally done, we simplify, we get an x squared plus an 8x plus 15. Notice that the coefficient of the middle term, 8x, is the sum of 3 and 5. Also, the constant term, 15, is the product of 3 and 5. To factor a trinomial of form x squared plus bx plus c, you must find the two numbers that have a sum of b and a product of c. Okay, so the two numbers have to multiply together to give you c, and you have to add them together to give you the b. So let's see what comes up out of this. Okay, example 1. Factoring x squared plus bx plus c. That's where we start the whole thing right here. I'll factor x squared plus 7x plus 12. And notice that all the terms, in this case, we're dealing with all positive terms in here. Okay, the 7x is positive and the 12 is positive. And this could be important as we move forward, that where the negatives are and how you think about them. So right now they're all positive. And when they're positive, you can factor the factors of 12. Okay, find the factors of 12. Identify the pair that have the sum of 7. So we're going to look for factors in 12 and find out how many of those factors you can sum them and come up with a 7. So it looks like we take the factors of 12 are 1 and 12. We have 1 and 12. We can add them together and get a 13. We can have a 2 and 6. We can add them together and we can get an 8, 2 and 8, or 2 and 6 is 8. Or we can take the 3 and 4 and add them together and get a 7. And it looks like, well, here's the check, right? It looks like the 7 is the answer because guess what? It's 7x. We're looking for a 7, and this is perfect. And on top of that, it's a positive 7. So if we take x squared right here plus 7x plus 12 and factor it, we're going to get the quantity. We get two parenthesized quantities here, right? They're binomials. I'm going to draw them in right here. You see them. And in the beginning, you're going to have an x term in each, x squared. Okay, we're going to multiply that out, x squared. Let's factor that out, an x in each place. Now what we have to do is we have to find the 12 term. And what was it? We found 7, or 2 and 3. So we're going to put a 3 in one of the spots and put a 4 in the other spot. And they're both positive. So the answer is right in front of us. It's x plus 3 and x plus 4. That's factoring of that trinomial, x squared plus 7x plus 12. Because 3 times 4, a little line right there. It's not a very good plus sign, but there it is. 3 times 4 is 12, and 3 plus 4 is 7. And there's what we're looking for. And to check it, we just have to take this right here and multiply it back and see if we come up with what we started with. And here it is. Here's the work is done. But if we do it, we can do it ourselves. First is x squared. Outer is 4x plus 4x. Inner is 3x plus 3x. Plus last. 3 times 4 is 12. And then, again, we talk about x squared. And we take and factor out the x. We get 4 plus 3 times x, using the distributive property, plus 12. And then we could simplify this. We're going to, that's a square there, sorry. And that's a plus. So now we have x squared plus 7. 3 plus 4 is 7. Plus 7x plus 12 is our final answer. Okay? Now we're going to go ahead and try some ourselves. So this is a check your understanding part of the problem. So you can stop this video and go try them out. And when you're finished, come on back and we'll do them together. Okay, we're just going to factor these. We don't have to even check them. Oh yeah, this one's asking for to check them. So we're going to check them. So let's factor these out. Okay, I'm going to assume now that you've come back. You've stopped the video and you've come back. So let's try it. The very first one is g squared plus 7g plus 10. So let's first, exactly what I always do. I bring out a couple sets of parentheses because I know that I'm going to need them. I take 1g in the beginning and of each binomial. And I know they're all pluses. We're going to have nothing but pluses inside. Okay? So what two factors of 10 can we add together and get a 7? Well, it looks to me it's not going to be a 10 and a 1. It looks like it's going to be a 2 and a 5. So we can, and it doesn't matter where we put it. I'll put the 2 here and I'll put the 5 there. We're done. If you want to check it, we're going to go back and check it. We're going to do FOIL on this. We're going to say g times g is g squared plus outer, g times 5 is 5g plus inner, 2 times g is 2g. 2 times 5 is 10. Take care of the inner terms here. The two inner terms, we have g squared plus 5 plus 2, g plus 10. And finally, we have g squared plus 2 and 5 is 7, g plus 10. And does that equal what we started with? Yes, it does. Okay, let's do B. Same thing. I'm going to put a paren and a paren and a paren and a paren. And I'm going to put the V's right here. And I'm looking for factors now of 20. That'll give us 21. Well, that's pretty straightforward, isn't it? We know we're dealing with pluses because that's all we have are plus signs here in our trinomial. So 20 times 1. Okay, so we're going to have a 1. We're going to put a 1 here, and I'm going to put a 20 here. Done. Now let's prove it. V times V for the outer is V squared plus, I'm not outer, first. Outer is 20V. 20V plus inner 1V. V times 20 times 1 is 20 plus 20. I'm going to simplify this. We're going to have, that was a 20V, by the way, right there. So V squared plus 20 plus 1, V plus 20. And now we can complete it with V squared plus 20 plus 1 is 21, V plus 20. There's our answer. To check it back, can we break this up? Can we break this apart? Oh, wait, no, this is, I'm sorry, we've already gone that far. We've checked it. We've just done the check on it. So the v squared plus 21, v plus 20 is what we're looking for. V squared plus 21v plus 20. This thing was so fast we've completed it before we even knew it. Let's do the next one. C. I start off with writing two sets of parens. Put an a in the beginning because it's a squared, and an a in the beginning here. And then it's going to be two pluses because I know it is, because we have nothing but pluses inside the trinomial. So what two factors of 30, positive factors of 30, can give us a positive 13? Well, it's probably going to be a 10 times 3. 10 times 3 is 30. 10 plus 3 is 13. So I'm going to put a 3 here and a 10 here. It's factored. So now, what do we have to do? Let's check it. To check it, we're going to say our first is a squared plus outer 10a plus inner 3a plus 3 times 10, 30. Now, without going through the distributive property, I think we can go right straight to adding 3 and 10a and get 13. So a squared plus 13a plus 30. Done. Okay, example 2, factoring x squared minus bx plus c. Well, as you notice, we have a negative term in here, and it's in the middle term, and it causes us to think a little differently about how we're going to factor it. And what it says here is some factorable trinomials have a negative middle term and a positive constant term. If the middle term is negative, you need to inspect and only inspect the negative factors of C to find the factors of the trinomial. And when they say the negative factors, they mean only the negative valued ones. And why is that? Because you have a positive here for 42. It's positive 42. So that means in order to get a positive by multiplying, you can either multiply two positives together or two negatives together. But if you're going to multiply two negatives together, you need to multiply two negatives together if you're going to add two negatives to get a negative number. So the only way you can get a negative number is in this case with the 42 is by adding two negative factors. Since the middle term is negative, find the negative factors of 42. Identify the pair that has the sum of negative 17. So as we go down in the little table here, we see we have a negative 1 and a negative 42. Well, that's negative 43. We want a 17. We have a negative 2 and a 21. Negative 21 gives us a negative 23. Doesn't get us there, but we have a negative 3 and a negative 14. Because 14 times 3 is 42. And negative gives us negative 17. So there's our numbers. So that's how we're going to factor this. So we say d squared minus 17d plus 42 is equal to, we're going to factor it, d, and d is the first number, the first values in our binomials here. And then negative 3 and negative 14. So that's it factored. So it's d minus 3 times d minus 14. And if you multiplied it back to check it, d times d is d squared. Outer d times negative 14 is negative 14d. And then the inner is negative 3d, and then negative 3d, negative 3 times negative 14 is positive 42. Okay, good. So let's do some work on our own here. Check your understanding. We're going to pause the video when you're done, and then when you come back, we'll continue on, and we'll try and solve these together. Okay, I'll wait for you. Okay, assuming that you've paused it and you've worked these, let's go ahead and try it ourselves. And they're not asking for us to check it. They just want us to factor them. So let's just factor them. So what do? As I said, you write two sets of parens. Leave yourself some space. In the first position, you put a k and a k, because that's what it is. Okay? And then we have a 25, and we need two factors that are going to give us a negative 10. Well, again, it's a positive constant C term and a negative B term, which means the only way we can get that is to have two negative terms to give us a positive 25. If we had a negative and a positive, we'd have a negative 25. We need a positive 25. So the only two negative terms that'll give us negative 10 are negative 5 and negative 5. Because that'll give you a positive 25, and a negative 5 plus a negative 5 is a negative 10. Okay? How about the next one? Sets of parens. I don't even know what it is. We're just going to get them out there. X and X for our X squared. And we have an 18 positive and a negative term on the inside. So that means that we have to have two negatives. Because it's a negative here, we have to have negative factors of 18. And negative factors of 18, that'll give us 11, are what? Well, 18 and 1? No, that won't give us 11. 9 and 2? No, 9 and 2 will not give us, or will it? 9 and 2 is, oh, look at that. Yep, it will give it to us, won't it? So we're going to take a negative 9 and a negative 2. That's it. That's the solution. X minus 9 times x minus 2 gives us x squared minus 11x plus 18. Let's try this one. Two sets of parens, q and another q. What 36 factors, which are negative factors, will give us negative 15? Well, the only ones I can think of is probably 12 and 3. 12 and 3 gives us 15. And 12 times 3 gives us 36. So I'm going to put a negative 12 and a negative 3. Okay? Q times Q is Q squared. Minus 15 here we're looking for. Minus 12Q and minus 3Q gives us minus 15Q, and negative 12 times negative 3 gives us 36. In example 3, we're going to be factoring trinomials with a negative C term, a negative C. So it throws a little hook into what we're trying to do here, but you'll see. For the negative C, we have to have a positive and a negative term. Anytime to get a negative C term, it has to be, one of the factors has to be positive and one has to be negative. Because a negative times a positive is a negative. Okay, so let's say when you factor trinomials with a negative constant, you will need to inspect pairs of positive and negative factors of C. Okay, the factor, they want us to factor m squared plus 6m minus 27. Identify the pair of factors of 27 that have a sum of 6. So looking in the table here, is 1 in 27 give us a 6? No, it's a 26. Okay, how about 27 and negative 1? Gives us positive 26. We're looking for 6. How about 3 and negative 9? That gives us negative 6. And then, so you see they're all opposite. Positive, negative, negative, positive, positive, negative. How about 9 and negative 3? Yes, 9 minus 3 is 6. So we found the factors 9 and 3. So in order to solve this problem, they're right here. We're going to say, we would be saying m squared is equal to, and I have the factors already done here, m times m over here, and plus 9 and minus 3. You just place them in the binomial positions. Okay, over here for factoring p squared minus 3p minus 18, you notice the difference? This one here has a positive on the middle term. This one has a negative on the middle term. Not going to make much of a difference. Well, let's take a look at it. Identify the pair of factors of negative 18 that has the sum of negative 3. Okay? Before we were looking for a positive 6, now we're looking for a negative 3. Well, if you look at them, you're going to see 1 and negative 18 is negative 17. That won't do it. 18 and 1, or negative 1 is 17. That's not going to do it. How about negative 6 and 3? That'll give us a negative 3. Negative 6 plus 3 gives us a negative 3. And that's it. And that's a factor. Negative 6 times 3 gives us negative 18. So as we factor this out, we're going to find out that we can, it's already done, but I'm just going to write it again just so we do it. Put a p here and a p here because there's p squared. And we have the negative 6. We have to just plunk in a negative 6 and a positive 3. And it was already plunked in for you. So, okay, that's the example. Now we're going to do some. Check your understanding. Factor each expression. You can go ahead and stop. And stop and pause the video. Do these yourself. And when you come back, we'll try them together. Okay, I think you're back. Let's give it a shot. For A, sets of parens. M squared. The firsts get m's. Now, what factors of negative 20 can give us a positive? So negative 20 means you have to have a positive and a negative in order to have a negative at this point. And since it's a positive in the middle term, that means that the largest term, the interesting thing here you need to know, the largest term has to be the positive term because you're going to subtract from it and you have to get a positive number. If it was opposite, you'd have a negative number. So what two factors of 20 will give you a positive 8? Well, I think we're going to find out that if we had a 2 and 10 gives us 20 and 2 and 10 can give us an 8. So the 10 needs to be the positive term because we're going to subtract 2 from it. If it was backwards, it would be a negative 8, right? Or negative 20 plus 2. So we're going to have a positive 10, and a negative 2. And then 10 and negative 2 gives us a negative 20. And the 10m and the negative 2m gives us an 8m. Let's try B. Two sets of parens. P from the p squared. Now, this is negative and negative. So what this is, it's exactly the opposite of what I told you on A. On A, see, it's a negative 40 right here, negative 40. So that means that you can only have a positive and a negative to get a negative. But now you need to have a negative term in the middle. To have a negative term in the middle means that your negative term must be the larger term because you have to add to it and still be negative. So what are they? What are those terms? Well, it's not 40 and 1. It's probably, let's see, 8 times 5 is 40, and 8 and a 5 gives us 3. So what is it? We need a negative 8 because the 8 is larger than the 5. So we need a negative 8 and a positive 5. So the larger number, the larger of these two, the x, the minus, the negative and the positive, is for this sake is the 8, and the smaller number is the positive 5. And that'll give you a negative 3 because negative 8 plus 5. Okay, I hope that's making sense. Okay, let's go down here and do this same thing. It's two negatives. This is one I like. So we're going to have a parenthesis, paren, open, close, y squared. So we're going to break the y's apart. And now again, it's 56. What two factors of 56? We need a positive and a negative factor because it's negative. And the negative term will have to have the larger of the two factors. Okay, the negative term. So what times 56 times what? To give you, well, obviously it isn't 56 and a 1. It's probably somewhere way close down to like 8 times 7 is 56. And when there's a 1 difference between them. And we're looking for a 1. But since we're looking for a negative 1, guess what? The term that has to be negative is 8. You're right. You got it. And the positive term has to be the 7 term. Because now you can subtract 7 from negative 8 or add positive 7 to a negative 8 and get a negative 1. So now we're going to put in here a negative 8 and a positive 7. Done. Good job. I think you got it. I think you have it. But keep in mind this negative and negative and negative and positive. Go over this slide a couple times if you want, until it like sinks in. This is an important key because this gets confusing if you're not paying attention to, well, I do the positive, the negative. It's simple if you know which terms you're looking for. Okay, good deal. Okay, we're on example 4, factoring trinomials with 2 variables. And yes, I know that sounds difficult, but it's not really. We've separate the like the x squared term very simply. Well, you'll be separating the other variable, whatever variable it happens to be, very simply too. So you'll see how it's going to work pretty smoothly. So it says factor h squared, that's our one variable squared, minus 4hk. So now you have one of each variable in there in the middle term, and then minus 77k squared. The other squared variable is at the back end, at the end of the trinomial. So it says identify the factors of 77. Identify the pairs that have a sum of negative 4. And just like before, we can start right off. We know that we're going to have positive and a negative because you need a positive and negative to get a negative right here. You cannot get a negative here without having a positive and a negative. 2 positives will give you a positive. 2 negatives will give you a positive. In order to get a negative, you have to have a positive and a negative. And it doesn't matter which one. You just have to have them. So however we decide to switch them around for the middle term is irrelevant to this 77k squared. So when we look down the terms, we have 1 and negative 77. That's negative 76. Ain't going to help. 77 and negative 1 is 76. That's not going to help. But we look here, we have a 7 times a negative 11. And that's 7 and 11. There's a difference of 4. We're looking for a difference of 4. Negative 11 and a positive 7 give us a negative 4. That's exactly what we're looking for. And as we were talking about it, the larger term is the negative term. The smaller term is the positive term. Because when you're done doing your adding or subtracting, however you want to think of it, you don't want to end up with a positive number. You have to end up with a negative number. The only way to do it is to have your larger number be the negative number so that you can subtract a smaller positive and stay negative. So when we do that over here, we see it. We factored this out. We said h and h with the 2 sets of parens like I generally do here. And then you can, the other term here is you have an 11 minus 11k and plus 7k. Just from here, minus 11 and a plus 7. Okay, so those are our terms. So when we do this, we're going to have a h times an h to give us an h squared. We're going to have an 11k. Oh, I guess I should have done the last. So we're going to have h times 7k. We're going to have a 7hk. Right? There's the k, and then there's the h here. So you're going to have I'll write it out. You're going to have a h squared. Then you're going to have a 7, doing the FOIL, a 7hk. And then you're going to have a inner negative 11k h, negative 11. I'm going to write hk. I can switch them around. And then finally at the end, I need to have a negative 77. So negative 11 times 7, and it's k times k is equal to a negative 77k squared. You see how that was done? Okay, now we're going to have a few to do ourselves, so let's give it a look. Okay, so for example 4, check your understanding. Let's give these a whirl. You can stop the video and go off on your own and try it. When you come back, we'll continue on and do them together. And if I think you're back now. If you've stopped it, you've already stopped it and come back. So let's take a look at these. 3 problems. So the first thing to realize is that they're not really much different than the previous ones we were doing. Okay, so I'm going to start off like I've always done. I'm going to start off with a parenthesis. I'll make it bigger this time because there might be more numbers to slide around. So the x squared is in the front. I'm going to put the x squared in the first location. Just get it out of the way. The y squared is at the end. I'm going to put the y at the end. So now I have an x and a y, x and y. I don't know whether there's a positive anything or negative. I don't care at this point. But my x's and y's are taken care of. I don't have to ever think about them again. Just multiply them correctly and carry them through. So now I have to find, I have a positive 24, and the only way to get a positive 24 is to have two positives or two negatives. And since the 11 is positive, the only way to probably get that is to have two positives, right? So 24, what factors of 24, positive factors of 24, will give us a positive 11? Well, I think 8 and 3. 8 times 3 is 24. So an 8 and 3 is 11. So I'm going to put, and they both are positive. So I'm going to put a positive here. It doesn't matter where I put it. I'm going to put an 8 here and a positive and a 3 here. And that's done. If you do it back, you'll see it's 8x times x is x squared. X times 3y is 3xy. And then the inner 8y times x is 8xy. Okay? And then finally at the end you have 8y times 3y is 24y squared. And the 3y and the 8y add together and you get 11. 11xy, 3xy, and 8xy gives you 11xy. It's really just that simple. I'm sure you're seeing it. Another set of parentheses. Makes it easy. Start off with the one variable in the front, the y in this case, and the w in the last location. Now the y's and w's have taken care of themselves. So now we have 48, and we're looking for a 2, a positive 2, and that's good because we have a negative on the 48, which means we can have a positive and a negative. We must have a positive and a negative. One positive and one negative. And since this is positive, right here, what does that mean? It means that the positive number must be larger than the negative number. So what two numbers can we put together that get near 2? So, well, it's not 20, it's not 24 and 2, so it's not 4 and 12, but it looks to me like 6 and 8. 8 times 6 is 48. And if we want a positive 2, so I'm going to say that it's a positive 8 and a negative 6. Okay? If someone's missing it, please just write a comment in the bottom of the video. I'll look at it. I'll answer it directly for you if you need help. Going to the last problem. I think this is the absolute last problem in this section. So we're going to make the parens again, like I always like to do. Just get the logistics out of the way. How's that? Put the m in the front and an m in the front. In the next section, I think we're going to have some kind of a coefficient in front of the m, so I might not be able to put the m's so close to the front, but we'll worry about that in the next section. So we have m's and we have the n's, n squared, so we have n's in the last positions. So now we have a 60 negative, so that means a positive, again, that means a positive and a negative. And we need a negative 17. So that means that the larger number is going to be negative. So what is that? 60, what factors of 60 can give us 17? Well, it comes quickly to me because it could be 3 and 20. Because 20 minus 3 is 17. But guess what? We want the 20 to be the negative, don't we? So we're going to say negative 20 and positive 3. Negative 20 and positive 3 gives us negative 17, and it's NM and M all taken care of. I'm sure you got this. If you didn't, make a comment. Write a comment and ask. I would be glad to go over it again. I'll even make another video if we have to. Thank you.